You already know TypeScript's basics: types, interfaces, classes. This video is about what comes next: writing code that's reusable without giving up safety, catching bad data before it reaches production, and building one real, fully typed app that talks to a live API. We'll move through 5 lessons from Level 2 of the TypeScript Mastery Path, each one building on the last. First stop, generics. If you've ever written the same function twice, once for strings, once for numbers because you didn't want to fall back to any, generics are the fix: one function, many types, and the compiler still checks every call. Here, T stands in for whatever type gets passed in. Call it with numbers and T becomes number. Call it with strings and T becomes string. TypeScript infers it automatically, and it still stops you from calling to fixed on a string. K extends key off T constrains the key to an actual property on the object, so get property for a real field just works, and asking for a field that doesn't exist, like email here, fails at compile time instead of quietly returning undefined. Classes get the same treatment. This stack works identically whether you push strings or numbers. One implementation for every type and pops return type. Honestly says T or undefined, because popping an empty stack really can happen. Type parameters can default, too, just like function parameters. API response defaults T to unknown rather than any. Unknown still forces you to check the value before using it, while any would let anything through completely unchecked. This result, type OK true with a value, or OK false with an error, is a pattern you'll see again in the async lessons ahead and in the weather project at the end. With reusable, type-safe building blocks in hand, next we need to make sure runtime data actually matches what we claim it is. Second, type narrowing in guards. A union type like string or number only gives you the methods common to both until you prove, with actual runtime code, which one you've got. That's narrowing, and it's the discipline that keeps a compile time promise honest at runtime. A plain type-off check narrows a union step by step. Once you've ruled out undefined and string, TypeScript knows the only thing left is a string array, so join just works without another check. Instanceif does the same job for classes. Check the more specific subclass first, validation error before the general error, because a broad instanceif error check would swallow every subclass if it came first. The in operator narrows by checking whether a property exists, handy for a union of object shapes that don't share an explicit tag. If vehicle has a drive method, it's a car; otherwise, sail tells you it's a boat. When the built-ins aren't precise enough, you write your own guard. isCoordinates returns value isCoordinates instead of a plain boolean. That specific return type is what teaches the compiler the narrowing, so describe location can safely read lat and lng afterward. Here's the catch: TypeScript trusts a guard's claimed return type completely. It never checks the function body against it. A guard that always returns true compiles fine and crashes at runtime, so test your guards directly. Next, let's point that same narrowing discipline at something that's always technically unknown, whatever a network call actually sends back. Third, async and await, with real types attached. Inside an async function, await unwraps a promise T down to plain T. The interesting part is knowing exactly what TypeScript does, and doesn't, catch for you when you forget to await something. You write the resolved type, promise of string, not a double-wrapped promise. TypeScript wraps a plain return value for you automatically. Inside main1, await hands back a plain string, already unwrapped, ready to call to uppercase on directly. Promise.all keeps each promise's individual type. Instead of flattening everything into one messy union, name comes back as a string, age as a number, active as a boolean, exactly as you'd expect. Since TypeScript 4.4, whatever you catch is typed unknown, not any a deliberate safety change, since JavaScript lets you throw literally anything, not just error objects. Instanceif error is the standard check before you touch message or stack. Async doesn't automatically mean parallel. Await 2 unrelated operations one at a time and you pay for both. Back-to-back, kick them off together with promise.all instead, and they run concurrently, same types, half the weight. For expected failures, a lookup that might miss many codebases return a typed result instead of throwing, forcing every caller to check OK before reading data. That same discipline, check before you trust, is exactly what you need the moment real JSON enters the picture. Fourth, what happens when a real fetch call meets your type system? Spoiler: by default, nothing does. Response.json hands you type any, which means TypeScript will trust absolutely anything you claim it is. This compiles cleanly, and that's exactly the problem. Nothing here actually verifies the server sent something shaped like a to-do. If the API changes, or errors, the mistake surfaces later, somewhere confusing, as a runtime crash instead of a clear type error. A very common bug, assuming every response is a success. Fetch only rejects on an actual network failure of 404 or 500 still resolves normally, so checking response.ok has to happen before you ever trust the body. This is where narrowing from the last lesson pays off directly. Type the parsed JSON as unknown, run it through a real guard like is to do, and only then is it genuinely, checkably a to-do, not just labeled one. Arrays need two checks, not one. Array.isArray confirms it's actually an array, and every rechecks that each element matches 2 without both. Something like an error object, or an array of the wrong shape, would slip through unnoticed. Package that whole pattern once into a generic fetch JSON helper fetch, check the status, validate, return, and every future call site gets a concretely typed, actually verified result, for free. This exact helper is what powers the project we're building next. Last stop, putting the last 4 lessons together in one real project: a typed weather dashboard built against OpenMateo, a free API that needs no sign-up and no key at all. Every shape gets its own interface, the raw API responses on one side, and separately, the weather summary the dashboard actually displays. Splitting what the API sends from what we show means a future API change can't quietly break your UI types. That's the exact generic fetch JSON helper from the JSON lesson, dropped in unchanged. T gets inferred from whichever guard you pass it, so every call site geocoding, forecast, anything you add later comes back fully typed, with no any anywhere. A record of number to string turns weather codes into readable text, and the newlish coalescing fallback means an undocumented code degrades gracefully to unknown conditions instead of printing undefined on screen. One config detail worth knowing: fetch needs the DOM lib and sconfig. Even in a Node project, Node has supported fetch since version 18, but its type declarations still come from lib.dom, not from Node's own types. Put it all together: typed fetch, validated JSON, narrowing, and generics, and you've got a small CLI that trusts nothing blindly, end to end. That's the arc: generics for reusable code, narrowing and guards to keep runtime data honest, typed async for promises that behave, validated JSON at the boundary, and a real project tying it all together. Every lesson here has a full write-up and runnable exercises. Links to all 5 are on screen now.